Hello class, we're on lesson number 3 in chapter 7, and this is involving more on solving simultaneous equations by addition and subtraction. If we take a picture, look at the picture here, we have the Golden Gate Bridge and the Golden Gate Bridge being constructed. And we read that it is one of the longest bridges in the world, extending more than a mile across the San Francisco Bay. It is more than twice the length of the longest suspension bridge in existence at the time that was being planned. This photograph shows the bridge at an early stage of construction. At this point, catwalks had been hung between the two towers for the workmen, but the cables had not yet been built. A lot of mathematics must be worked out before a structure as immense as this one can begin. To make sure that the bridge would be able to withstand storms from the Pacific, one of the engineers on the project had to solve a system of 33 algebraic equations containing from 6 to 30 variables each. Now that's immense as the bridge. To imagine an algebraic equation having 30 variables, it's just that would be immense. Now it's a lot harder to imagine. Well, imagine doing that now. It'd be a lot harder, but as you learn math, it actually becomes a lot easier. I'm sure that it was still challenging. I certainly wouldn't challenge you with 30 variables. Let's turn over to page 298. From lessons 1 and 2 of this chapter, you've learned two ways of solving certain pairs of equations in two variables. The equations are either added or subtracted to produce the third equation that contains just one variable. So that's all we did in chapters 1 and lessons 1 and 2. Now here is a pair of simultaneous equations that cannot be immediately solved by either of these methods. What do we have? Well, we have 4x plus y, and that is going to be equal to 28. And then we have 2x plus 3y. Now we're challenged here because we simply cannot add and subtract and eliminate one of the two variables. If we added or subtracted, we would still end up with x and y's in our third equation. So we would end up with 6x plus 4y if we added them, and we would end up with 2x minus 2y if we subtracted the second. 2x minus 2y is equal to 4 in the second equation. So we have these two equations, 6x plus 4y is equal to 52 and 2x minus 2y is equal to 4, and neither of them are going to really help us to neither will help us to solve what either variable is. So we have to take a look at this from a different angle now. It says, although these are both perfectly good equations, they follow from the original equations and give us more clues about x and y. They still contain both variables. The reason that addition and subtraction do not eliminate x or y is that the original equations contain different numbers for the x's, and that's 4 and 2, and different numbers for the y, which would be 1 and 3. Now, one way to get around this difficulty is to multiply one or both equations by numbers such that the resulting equations do contain equal numbers of x's or y's. Now we can do this because we know that an equation can be transformed into an equivalent equation by multiplying each side. You have to multiply each side by the same number other than 0. So if we look at our original equations, we have them here. If we multiply each side by this of the second one by 2. So let's do that. We're going to multiply this one by 2. So that means we would have to multiply this by 2, but it also means we'd have to multiply the 24 by 2, right? So you see we're multiplying both sides by 2, and what would that give us? Well, it would give us 4x minus 6y, and if we wrote that down here, I'm sorry, 4x plus 6y, and 24 times 2 would be 48. Now if we look at the first equation and the new second equation, okay, this was the older one. Now we have a new second equation, and it's equivalent. It's equivalent simply because we multiplied both sides, so it kept everything in balance. Similarly, if we have something as simple as 1 is equal to 1. And I just show you that if we multiply this side by 2 and we multiply this side by 2, what will we get? 2 is equal to 2. So it remains true. So simply by multiplying each side by 2, we've changed the equation, but it still remains true. It's an equivalent equation, and now we have 4x's on both sides on both equations, which means that if we were to subtract, okay, we could then end up with, well, actually they're going to subtract the top one from the bottom one. So I'm going to bring the top one down here, and I'm going to write 4x plus y is equal to 28. Now, it's certainly a lot easier for us to subtract the smaller one from the bigger one. So you can go either way. You can subtract either from the other. And in this case, it's so much easier because we won't end up with a bunch of negatives that we'll have to deal with, which is fine, but it would certainly increase the difficulty. So now we subtract, and we end up with 5y is equal to 20. Now we can solve by dividing each side by 5, and we know that y is going to be equal to 4. Now we have not finished our work because we've only solved one equation. Now we can go ahead and plug it into one of these equations, and you'll see that they chose this one. It's really the easier one because y is equal to 4 here, and rather than multiplying, you know, sometimes it's just easier to use the simpler one, the simpler equation. So we have 4x plus 4, right? And that's going to give us 28. And now we can simply subtract each side by 4, and that would give us 4x is equal to 24. And dividing both sides by 4, x would be equal to 6. So we now know that our solution is, and if we write it as a coordinate, 6, 4, right? Because x is 6 and y is 4. So that is our point, or that is our solution. Okay, and we can certainly confirm that by plugging these numbers into our first equation and see if that's true. Okay, it's always good to double check. Now, we have a few more examples here. We have 4x plus y is equal to 28, and 2x plus 3y is equal to 24. And you could see that they've gone and they've solved this equation using, first by multiplying the top equation by 3, and then they were able to get two 12s, so to speak. Oh, I'm sorry, two 3s, not two 12, two 3s. And in doing so, they were able to subtract the second one and get 10x is equal to 60. Solving this for x, we would have x is equal to 6. Substituting the value back in, they find out that y is equal to 4. Now, in the second example, they have a little more challenging because there really isn't like one number that you could just say, let me multiply the equation to get 2x, you know, the x's or the y's to match up, because look, we have 7x, and I'll go ahead and just write this on the board. We won't necessarily do the entire problem, but we have 7x plus 4y is equal to 27. And here we have 3x minus 5y is equal to 25. Now the challenge here again is that we're not able to just multiply any particular one of these to get a number that would match. If I multiplied 2 by 3, I'd get 6. If I multiplied by 3, I'd get 9, so that won't match. 4 and 5, I mean, you certainly couldn't multiply anything by either. Certainly fractions, but we don't want to get into that. So what they did was they actually looked for a common, well, that's like the least common denominator when we're looking for those things, and we're trying to say, well, we have to multiply both denominators and try to figure out how can we make these denominators the same. Well, these aren't denominators, but let's view it as the same method. We have to multiply both of these equations to find a common, and one of the simplest ways is just by looking and saying, well, if I multiplied 4 by 5 and 5 by 4, they would both be 20, wouldn't they? So that's certainly one way to do it. And you can also do it just by doing 7 and 3. You can multiply this by 3 and this by 7. That will give you 21. Okay? So they chose to multiply the first one by 5. So by multiplying this by 5 and then multiplying this one by 4. Okay, and remember we'll have to do it on both sides. Very important. If you only do it on one side, then you've just completely changed your equations, and you would definitely get a wrong answer because you haven't really you've changed the equation, so to speak. Then you haven't made an equivalent equation. So by multiplying now, we have here these, we're going to use the distributive property, but note that when you multiply 5 by 4 and 4 by 5, we're going to end up with 20y, which we can then either add or subtract. In this case, since 1 is negative, they're going to actually add them, and they were able to solve that way. So that's the end of this particular lesson.